This video is on Grade 7, Module 3, Lesson 10, which starts out on page 59. So today we are going to get into something called angle problems, and we're going to use equations to help solve problems with angles. Now, angles are something that was covered early on, I believe in 6th grade, so you might have to think back a little bit. And here's a little reminder for you. An angle is a measurement, but not of a distance. An angle is a measurement of how much rotation, which means spin, is needed to change from facing one direction to another. So we'll take a look at some lines, take a look at some rays to see what I mean by that. But overall, that's the idea we're going with, is an angle is how much rotation is needed to change direction. The measurement that we use to talk about angles is degrees. So that's the units we use. You may get into some other units in high school, but for now we're going to stick with degrees. So degrees is the measurement of an angle. Just like we measure length in inches or feet, we measure angles in degrees. It takes 360 degrees to spin all the way around. So we kind of base everything else on that. So it takes 180 to spin halfway around, 90 degrees spin a quarter, and so on. Everything's based on that. So before we get into this chart here, we need to do a little review on angles. So on a separate sheet of paper, we're going to set up our own types of angle review chart. You're going to have to put the types of angle at the top of it as your title. You're going to need to save 2 lines underneath it for a little definition. And then our table that we have, we are going to need 3 columns across and a title row and then 4 rows going down. Should only have to take 1 page. So once you have that set, well, pause the video, create that table, and then let's start filling it in. So first thing we want to talk about is that angles are, as we talked about, how much spin or how much rotation is needed. But it's also formed whenever 2 rays share an endpoint. So remember, a ray is an endpoint with a line that extends forever. So we're going to see some pictures of that also. Make sure you got your column titles listed above, angle name definition, and then example, a picture example. First angle we'll talk about is a right angle. So a right angle measures exactly 90 degrees. So whenever we see that, we'll see one going straight to the side and one going straight up. Here's a little picture example of what I'm talking about. Again, we see one going straight off to the side and another ray going straight up. Something you do have to remember is that when you see this box right here, that is a symbol to show you that it is a 90-degree angle from here to here. So the measure of this angle is 90 degrees. All right, that's one type of special angle down. Next type of special angle is an acute angle. So an acute angle isn't just one measurement, but it's all measurements that are in between 1 degree and 89 degrees. Another way to think about that is any angle less than 90 degrees is an acute angle. Here's an example of what an acute angle might look like, but remember there can be several different types of acute angles. We see here how the angle measure this ray and this ray, the rotation needed to go from here to here is a lot less than it was up here for 90 degrees. So this is an angle measure less than 90 when it's acute. Third type angle measure is an obtuse angle. An obtuse angle is any angle measure that is in between 91 degrees and 179 degrees. A lot of people think of it as an angle that is just greater than 90. That's not exactly correct. Gotta make sure you remember it's in between 90 and 180 degrees. So again, that is always going to look like a certain type of angle, but not all obtuse angles will look exactly the same. Here we have an example of one. We can see here the rotation to go from facing this direction to now facing this direction. Here would be 90. We had to spin a little more than 90, so this would be obtuse because we had to rotate a little more than 90 degrees, or not even a little more, just more than 90 degrees. All right, and the final angle we will talk about is a straight angle. So remember, obtuse angle was an angle that was in between 180 and 90 degrees. Well, when we have an angle that measures exactly 180 degrees, that's called a straight angle. A straight angle actually looks similar to a straight line. We'll look at that in a second. So straight angle produces a straight line. And there we have our straight line right there. So again, this angle to rotate from facing one direction to the completely opposite direction takes a rotation of 180 degrees. All right, we are done with that little cheat sheet there, that little review sheet of types of angles. Let's get into angle relationships. So not just thinking about one angle now, we're going to be thinking about a pair of angles, or maybe 3 angles, or however many angles share a relationship. So we're going to go over the relationships right now. So the first relationship we will talk about is the adjacent angles. Now adjacent is just a fancy word for next to. So adjacent angles are angles that are next to each other. They're going to share a common ray or a common line as a side. Before I talk about the angle facts, let's take a look at it. So in our diagram, we have a few different angles going on. We have angle BAC and CAD. So angle BAC, let's see, we got it right there. I wish I could get it on a little better. So there we go, I just paused it and labeled one of our angles. So there we go, we got angle BAC. Now, when you're labeling angles, there are 2 different ways you can label an angle. You can label it with 1 letter or with 3 letters. You have to know how to do both. To do the 3-letter version, you have to make sure that your vertex, which is the point where they meet, so let's see, the point where the 2 rays meet is going to be at A. The vertex has to be the middle letter. So I could put angle BAC, or I could write this as angle CAB. It doesn't matter about the endpoints, whether B goes first or last, or same with C, but it does matter that the vertex is the middle letter. So the vertex is the point where the 2 rays meet in an angle. So there we have that. The other way I could label this is I could sometimes label them just using 1 letter, but I actually can't in this case, and I'll talk about why in a second. Another label we have, or another angle we have, is angle CAD, which I just outlined in that pinkish purple right there. So again, C, A, D, A had to be the middle letter because that's the vertex. That's where the two lines that make up CAD and DAC, that's where they meet at A. All right, so the reason I identified these two angles in this one is because if I look, I notice how these two angles, both the blue and the pink, share this line AC or CA. They share it as a common side. So that means BAC and CAD, those two angles, are adjacent because they're next to each other. They share a common side. They're just adjacent angles. Now the last thing I want to talk about is this angle BAD. So angle BAD, figure out a new color for it. Angle BAD is going to be this entire angle. So from here to here is angle BAD. So we're talking the measure of angle BAD would be from here, and how much rotation to end up from facing this way over by D all the way up to facing this direction now. Angle BAD, another way you could write that, or just angle A. And the reason I can label with just angle A is because angle A includes everything in this angle. It goes, when you use only one letter, you have to be talking about the outer rays. So you can't be, if you're going to use one letter, that does not include this this middle ray here. It's just the ray AD and the ray AB. So we would say this big angle in purple here contains adjacent angles BAC and CAD. All right, so one relationship between angles are adjacent angles, so just angles that are next to each other. The next relationship are vertical angles. So vertical angles, special note, they must use the same lines. So let's take a look at the example image of vertical angles. So we'll zoom in over here so it's easier to see. So vertical angles must use the same lines. So what am I talking about when I say must use the same lines? I notice here, so I have angle DCF, angle DCF, and angle GCE. So those are actually vertical angles. The reason they are vertical angles is because if I look, they share the same lines. We see here we have our line DE. It's used in angle DCF and in angle GCE. Also, so that's one of the two lines that they share. The other line that they share is FG. F and G, so they share the same two lines. So that's how we can tell that they are vertical angles. Now, what's so special about vertical angles? Let's take a look. Vertical angles another way to think of them is they're vertically opposite. So if you're looking at the angle measure, so A degrees and B degrees, We should write that down real quick actually. So angle DCF measures A degrees. A is a variable. We don't know the degrees, so that's why we use a variable. Angle GCE is using B degrees. Now again, we don't know what B is. It's a variable. That's what we use when we don't know what the number is. But we do know that vertical angles have the same angle measure. So vertical angles have the same angle measure. So I can put an equal sign here. So long story short, whenever you see a pair of vertical angles, like we do with A or DCF and GCE, you can say, oh, the measures of those two vertical angles are equal. They're the same. So if we know one of them, we know the other. All right. So we got two angle relationships down. Just two to go. Next one we're going to talk about is supplementary angles. Another word for supplementary angles, you can think of them as angles on a line. Remember, a line contains 180 degrees. Let's look at that for a second. So a line contains 180 degrees. So looking at this image right here, we can see we have line A, B, D. So that is a line, it's a straight line, ABD. It's also an angle measure. So notice we're facing this direction here. If I want to go from facing this direction to facing the completely opposite direction, that is 180 degrees. So we would say that, well, notice it's not just line ABD, we have a ray in there, ray BC. We would say angle CBD, which measures B degrees. So B degrees. And then notice, so that's part of the large 180 degree blue angle. The other part we have is, let's pick a color for it, angle A. So to go from BC all the way down to AB, we have to spin this measurement in green, which is angle A. So think about this. If I put B and A together, if I spun this way, this way, this way, well, that's angle B. And if I spun this way, this way, this way, this way, this way, that's angle measure A. So if I put them together, it means if I add them together, I would end up in the same spot as just spinning 180 degrees. So that's why we say they are supplementary. Or they're angles on a line, because if I add them together, they will equal 180 degrees. As I wrote down right there, so we have angle B, angle ABC, I should say, and CBD are angles on the line AD. So A degrees plus B degrees equals 180 degrees. All right, which brings us to our final angle relationship, angles at a point. So angles at a point, let's look at this. The point we're talking about here is point A. So A is the vertex. A is where we have three different angles really being formed. So the first angle we see, I see this D, A, B. Angle DAB. This goes from here to here, and we see how that gives us measure A. So that's A degrees. From there, we see how we have another angle. We have angle BAC from here to here, which is a measure of B degrees. And then we have angle measure CAD, which goes from here to here, right? Oh, I forgot to draw our lines. There we go. So, and we see how that measures C degrees. Something I noticed though is that here's angle again. I'll make this, here's my point, which is the vertex of all these angles. And I noticed that, okay, this was one part of the angle that goes around. This was another part of the angle that goes around. This was the third and final angle that goes around. Look at that. It forms a complete circle. So it goes all the way around a point. So let me remind you about something you wrote in the beginning. Degrees, measurement of an angle. It takes 360 degrees to go all the way around. Geez, my handwriting looks awful when you zoom in on it, so we're going to zoom out of that. But look at this. We went all the way around. That means that this angles at a point means that all the way around a point equals 360 degrees, just like we did with those three angles back there. So what can we say out of that? We can say, let's see, I gotta switch up some colors here. So the measure, that's what the little m stands for here, measure of angle DAB plus the measure of angle BAC plus the measure of angle CAD equals 360 degrees because those three angles go all the way around point A. Okay, so I took a little time, I color coded our, what do we got, 6 angles in this diagram. Let's talk about the angles that are vertical, then we'll go on to adjacent, and go on to the line, and then we'll go on to the point. So vertical angles, remember vertical angles are vertically opposite, but they have to share the same sides. So vertical angles, I'm going to, I want a highlighter, there we go. Vertical angles, I'll highlight in yellow. Let's see, so they have to share the same line. So I notice here how angle AEC is made up of line CD and AB. I also notice that angle BED is made up of those two lines. So I will say that angles AEC and BED are vertical. It's our first pair. Do we have any more pairs? We do. I also notice that CEB and DEA. So let's see. CEB. CEB is actually a combination. CEB Sorry, there we go. CEB is a combination of CEF and FEB. So CEB is a vertical angle. Let's see what line. So this line and this line. So what is vertically opposite? We see AED is opposite. So you would say angle CEB and angle AED are vertically opposite. So already saw that. All right, on to adjacent angle. Let's switch up the coloring. So adjacent angle will highlight in this green. So adjacent angles, remember, mean that they're next to. They have to share a common side. So we're going to have a whole bunch of adjacent angles. Any angles that share a side are going to be adjacent angles. So let's see, we could have right here, here's a side. So I could say that angles, first pair could be angle AEC and angle CEF. Another one could be, we could pick a whole bunch of them. Let's see, we could do right here. Angle DEG. And angle GEA could be a pair. There are also DEG and BED. Those are adjacent. BED and FEB are adjacent. FEB and CEF are adjacent. Whole bunch of adjacent angle pairs in this one. We don't have to list all of them though, just listing some examples. All right, let's talk about angles on a line. Angles on a line, we'll put those in blue. Why not? So to be angles on a line, well, first off, you have to have a line. So let's see, what lines do we have here? Well, we have line CD. So what angles make up line CD? We could say angles, so we'll just say for CD, that symbol there means line CD. We could have angle CEF, angle FEB, and angle BED. Those three make up my line. I also could say this. I could say or angle AEC You might be able to guess the other two. Angle GEA and angle DEG. So you kind of see it going the other way. We see how these three angles also make up that line. And you could talk about some other lines. You could talk about, doesn't have to be just line CD. You could talk about line AB, in which you would include these three angles as angles of a line or on a line. Or you could include these three angles as angles on that line, top or bottom, up to you, just as long as the angles add up or combined or put together form a straight line after you're done doing all that rotation. Okay, so angles on a point. Angles on a point, let's put that in this pinkish reddish type of color. Angles at a point. Well, the point that all angles originate on, so remember, angles at a point have to go all the way around a point. Well, the only point that has angles that go all the way around it is point E. Remember, that's going to be every single angle that goes around point E. So it's going to be all 6 of these angles put together. So it's going to be angle AEC, CEF, angle FEB, angle BED, angle DEG, and angle GEA. All those make up the angles around the point E. And it's kind of interesting because look at this. Every single one of them has E as a center letter, which it's supposed to because that's the vertex for each of those angles. Okay, so moving down to some examples, we have 4 examples in which they're going to ask us to estimate the measure of x. We have to do a little work with what we know about angle relationships and with what we know about equations in this to answer that. I'm going to do the examples. I will also do the exercises, but you guys will have to kind of work on exercises on your own. You're going to have to answer questions before you see how it's actually done. So, into example 1. So example 1 is asking us to estimate the measurement of x, and we see here how x is the unknown angle measure right there. So in a complete sentence, describe the angle relationship in the diagram. So something I notice is that we have a line BD and we have a ray coming off that line. So we actually have 2 angle measures here. We have angle measure CAD or DAC, doesn't matter which one you put as long as A is in the middle, and angle measure BAC. And those 2 angles, so if I spin from here to here, and then spin again and go from there to here, that gets me from facing one direction to facing the completely opposite direction, aka that makes up a line. So I would say the relationship is that BAC and angle CAD are angles on a line. So there we have it. We have angle BAC right there, and angle CAD right here. Okay. So what do we know about angles on a line? Well, if you look at your chart above, angles on a line add up to 180 degrees. So therefore, the measurement of angle BAC plus the measurement of angle CAD equals 180 degrees, because they add up. When we put those angle measurements together, or we put those angles together, they form a straight line. So they're two angles on a line. It doesn't just have to be two, but in this case, it is just two. So the next part says, write an equation for the angle relationship shown in the figure and solve for x. Then find the measures of BAC. And then it says confirm your answers by measuring with a protractor. We are not going to use a protractor in this. We're going to rely completely on our understanding of angle relations and algebra. So what do we know? I rewrote the relationship. We found angles on a line equal 180, or they add up to 180. We know the measurement of angle CAD is 132 degrees. So I'm going to put 132 degrees here. Now, the measurement for angle BAC, they don't tell us a number, but they give us that it's x degrees. And that's what they want us to find. They want us to find the measurement for x. So if x plus 132 equals 180, well, I can get x alone by just subtracting 132 from both sides. X will equal, or x does equal, 48. Just going to make sure I have my degree markers in there. So, the angle measure of angle BAC equals 48 degrees. So with that in mind, if I go down below, taking a look at exercise 1, so this is where you have to answer the following questions. I will show it out, but you have to answer questions first. So it says, in a complete sentence, describe the angle relationship in the diagram. Well, I notice how, again, we have line BAE. And then now I notice I have three angles on that line. The first angle on that line is angle EAD. Then I notice I also have angle, from there I have angle DAC. Then from there I have angle CAB. All those are angles on a line. So I'll say these three angles make or are on and complete, because it makes it all the way from facing one direction to the complete opposite direction, line BAE. So since they are all angles on a line, I know that when I add all those measurements up together, they equal 180 degrees. So what do we do with that then? Well, let's talk about what we got here. So angle angle EAD has angle measurement 2x degrees. Again, we don't know exactly what the angle measurement is, but we know it's 2x degrees. Then we have angle measurement DAC. So there's no number here, and there's not even something with a variable there, but I do notice this symbol right down there. So that means it is 90 degrees. That's the right angle symbol. Then angle CAB has 3x. So those three angles add together equals 180 degrees. From there, well, let's see what we can do. I know that I can take 2x and 3x, and I can actually add those to be 5x plus 90 degrees stays plus 180 degrees stays. And look at this. Now I just have a two-step equation. So I can go here, I can subtract 90 degrees from both sides. That'll leave me with 5x degrees equals 90 degrees. And I just say, oh, what is 90? I'd have to divide by 5. And we'd be left with x equals 18 degrees. All right, but that's not it. So x equals 18 degrees, but notice that they wanted us to find the angle measures BAC, which is in purple. I wrote that as CAB, BAC, CAB, same thing in this. And we have to find the angle measure DAE, which I wrote as EAD, which remember was 2x. So let's see. For angle measure BAC, that equals 3x. Angle measure BAC now equals 3 times 18, because x equals 18 degrees. So angle measure BAC will equal 54 degrees. There we have it. There's one of our answers. To find out D, or measurement of angle DAE, which I wrote as EAD, I remember that that's equal to 2x Same deal, instead of X, I'll put 18 degrees. So measure of angle DAE will equal 36 degrees. Okay, down to example 2. So example 2, in a complete sentence, describe the angle relationship in the diagram. So first we have to find out the angle relationship that's going on. Something I notice here is that we have, let's see, what color did I do it in? Well, we have two lines going on here. We have AB and KL. So, and well, it's AEB and KEL. So two lines makes me think of vertical angles. Vertical angles are formed when you have angles opposite of each other. So let's see, we have this line and this line. So I notice that here we're going to have angle measurement LEB and KEB. Those are opposites of each other. So they actually have the same angle measure because they are vertical angles. They are opposites of one another. So they are vertically opposite angles, so I can say that angle AEK and angle LEB are vertical angles. I can also say that angle LEA and KEB are vertical angles. I also have some other stuff going on. I notice how I have a line. I have line AB. So what can we say about the line? We can say this angle and this angle. So that will be BEL and angle LAE or LEA are angles on a line. And on that same line, I could say angle AEK and KEB are also angles on a line. All right. So we have relationship here. We know that these are vertical angles. Vertical angles are equal. And then right here, we have some angles on a line. We know angles on a line add to 180 degrees. So what are we asked to find here? We're asked to find x and y. So let's do this first. We know we erase some markings here. So AEK, or no, I'm sorry, LEA, LEA, and KEB, we know those are vertical angles. Vertical angles have equal measures. So angles LEA, that is equal to angle measure KEB because they are vertical angles. Well, what's the measurement of LEA? Angle measure LEA is equal to 144 degrees. For KEB, all they give us is its Y degrees. But that's okay, because right there we found out Y must equal 144 degrees. So that is good news because that tells us KEB, so angle measure KEB equals 144 degrees. Let's talk about LEB. LEB is from here to here. Now I know that that is an angle on a line of line LEK. So that angle plus this other blue angle has to equal 180 degrees. So angle LEB plus angle KEB has to equal 180 degrees. So they tell us LEB is x degrees. plus now KEB, they tell us is y degrees, but actually we just found out angle KEB equals 144 degrees. Both those add up to be 180 degrees. So if I want to find out what x is, all I have to do is subtract 144 from both sides, 144 degrees from both sides. X will equal, or x degrees equals not 100, 36 degrees. So I would say the angle measure of LEB equals 36 degrees.